We've got an awesome topic here to get things going here with limits. So we're finding limits graphically here today. And again, a real quick review of some of our basic definitions. Again, a limit measures a function's what? Not its actual height, but its intended height. And of course, as the input values, those x values, get closer and closer and closer to a specific value, we ask ourselves, what are the output values? What do the heights get closer and closer to? So our first live example, we've got function h of x. And we want to find the general limit here as, let's see, is this my highlighter? Here's my highlighter. The general limit as x approaches -3, or actually, not the general limit, is it? We're approaching -3 from the left. So what we want to do is, of course, if here's -3, you want to jump just to the left of that bear. So what you want to do is maybe position yourself right here. Maybe we'll draw ourselves a cute little stick figure. There you are. And all you're going to try to do is walk a little closer, a little closer, a little closer as you continuously get closer and closer to x equals -3. Now, as you're getting closer and closer, what is your heights getting closer to? So you're starting off with about a height of 8 roughly. You're getting, dropping to 7.5, 7, 6.5-ish. You're getting closer and closer to 6. So what I'll say, using good notation, and this is what you want to, when you write these on your own paper and as you prepare to take a picture and submit them, always rewrite the notation here. You want to practice having great notation. Okay, we're going to say equals 6. Now, what are some common mistakes? A common mistake is that students are going to look at this open circle right here. Okay, you see this open circle? Highlight it with the pink. That students look at that open circle and they automatically assume that the answer is going to be does not exist. And the reality is, again, because it's about intended height, not actual height, whether this rascal's open or closed has no bearing on your final answer. My answer was going to be 6, whether this was open or closed. Now, just for good practice, what would the limit be from the right-hand side? What is the limit as x approaches -3 from the right-hand side? So now we want to jump over here and just inch your way a little closer, a little closer, a little closer to -3 from the right-hand side. And now you're approaching a height of 2. Again, it's a closed circle. We don't care whether it's closed or if it was open. My answer is going to be 2 either way. All right, let's shimmy and shake our way down here to number 2. So we've got some really interesting things going on. And in this example, I want to target x approaching 0. And so ultimately, I want to be able to determine what is the limit as x approaches 0. And that's what we call a general or a two-sided limit. Before I can answer that question, I first have to check to see what is the limit as x approaches 0 from the left. And what is the limit as x approaches 0 from the right? Okay, so from the left-hand side, I want you to pretend, of course, here's 0 right here, so we want to jump to the left and just walk a little closer to 0, and we're approaching a height of 0. But if I want to approach 0 from the right-hand side, I jump over here, and I walk a little closer, a little closer. Notice the corresponding x values are getting closer and closer to 0, and now we're approaching a height of 2. Now you'll notice those two answers are not the same, so my general limit does not exist. That's my symbol, the shorthand notation for does not exist. And again, we'll say it again, these one-sided limits have to have the same answer in order for the general limit to exist. All right, let's take a look at same picture. Let's ask ourselves what's happening as x approaches 2. What is the limit as x approaches 2? Now, again, we're going to break this down. We're going to kind of step back for a second and do the one-sided limits. What is the limit as x approaches 2 from the left? And what you'll see happening here is pretend you're standing right here and you're just going to walk a little closer, a little closer, a little closer. And it looks like we're approaching a height of -2. Okay. Now, what is the limit as x approaches -2 from the positive 2? I don't know why I said -2. Positive 2 from the right-hand side. So we use that little plus sign for the right-hand side. And let's say, all right, let's start ourselves here. We're going to go closer. We're walking closer and closer and closer to 2 from the right. We don't care whether that's open, whether we're approaching an open circle or a negative or a closed circle. Jeez Louise. In that case, we are approaching a height of 0. Our intended height is 0. Our actual height doesn't exist from that side, but it's intended to be 0. Again, those two numbers do not agree, so our general limit does not exist. I got to try to pull it together here. Okay, example number 4. Okay, any predictions which number we're going to look at? Yeah, let's look at x equals 4. What is the limit as x approaches 4? Just like the other problems, we're going to rewind and take a look at both of the one-sided limits before I make a determination as to whether the general limit exists or not. So my limit as x approaches 4 from the left. Let's see. So I got to start just to the left of 4. Maybe I'm going to start around in the neighborhood of x equals 3, walking closer and closer to 4, and I'm approaching a height of 4. So as x approaches 4, the function approaches a height of 4. How about that? What about the limit as x approaches 4 from the right-hand side? Ooh, look at that. Looks like we're also approaching a height of 4. So we could say the limit as x approaches 4 from the right-hand side also equals 4. These two numbers are the same, so we'll say the general limit does exist, and it equals a value or a height of 4. I'll put a little smiley face there. Winner, winner, chicken dinner. We finally got one to exist, huh? Here's a really fun activity I want to finish with. We're going to do just the opposite. Instead of giving you the graph and asking you to evaluate those limits, we're going to do the opposite. We're going to give you the value of the limits and see if we can reverse engineer this process and draw a sketch of what that graph might look like. So what we know is, and it looks like I've got a little typo here, this should be a plus sign right there. So you can make that adjustment in your notes. Okay, so the first thing I notice is that the limit as x approaches 4 from the left equals 6. So what that tells me is, let's see. So we're approaching 4 from the left. There's x equals 1, 2, 3, 4. All right. We've got 1, 2, 3, 4, 5, 6. Okay. We'll say 6 is right there. What I'm going to do is I'm going to start by marking an open circle at what I think is the point 4, 6. And I don't have enough information just yet whether to that circle should be closed or open. So I'm just going to leave it open for now. And I may come back later as I read the rest of the given and close it up, okay? And what I'm going to do is, because this was from the left-hand side, right? We were approaching 4 from the left. I'm going to put a little tail on that side. Okay, the next criteria here, they said as x approaches 4 from the right, the intended height is 2. So, okay, so let's say 4, 2. So 4, 2, I'm going to, whoopsie daisy, there's an open circle. I'm going to put a little tail on the right-hand side. And then the last thing they mentioned here was that f of 4 equals -1. That, in our notebook, we could say that's the function's actual height, okay? And that's where you put your closed dot. So these two are always start off as open. And then this one represents your closed dot. So I'm going to put a closed dot at 4, -1. Let's put them right there. And then my function, and here you can be creative. You can make up anything you want. Zoop, zoop, zoop. All right. And that's what f might look like in that sense. So we've got open circle here, right? Open, we're open, and then we're closed there. Now I said these ones always start open. What happens is, let's pretend instead of saying -1 right there, maybe they said this was a 6, f of 4 equals 6. Then I would have went back and closed that one, okay? Or maybe they said f of 4 equals 2. Then I would have went back and closed that one. So there's sometimes this number may cause you to go back and close one of those open circles. But in this case, I'm going to leave them open. So let's see if I can erase. Oh, dear. Okay, well, that's not the end of the world. I can always draw an open circle right there. So those open, close. Hope that makes sense. Let's go test our luck with an assignment, eh?